Okay, today's topic is Industry 4.0, and in particular, the four emerging technologies that are transforming manufacturing today. We will cover transformative technologies like 5G, digital twins, AI data management, and edge computing, and explore their impact on the manufacturing industry. My guest today is Todd Edmunds, who is the global CTO of industrial IoT and edge compute, as well as a strategic innovation and technology leader at Dell Technologies. Welcome, Todd.
Bernard, thanks for having me. I'm honored to be here and excited to have a conversation with you.
Likewise. Todd, where are you joining us from today?
I am in Kansas City, right in the center of the United States.
Very good. What's the weather there like today?
It's very, very cold, 5 degrees Fahrenheit, which is very, very cold wherever you are.
Yeah, we haven't got the snow yet. Or did you get some? Did you get
We've
lots of
got snow and then it goes away and then it comes. It's in the middle of the United States. The weather changes frequently, so it may be 70 degrees in a couple days. We don't know.
No. So in your role as global chief technology officer at Dell Technologies, you focus on the industrial Internet of Things and edge computing, and outside of Dell, you also lead the manufacturing work group for the Digital Twin Consortium, and you chair the edge computing task force for the Industrial Internet Consortium. So this is I guess it sounds very busy. What do you do? What does your day look like? What does it mean in practice? What do you do?
I'm tired just after you reading all the things that I'm involved in. So I get to help our customers and our partners at Dell Technologies understand the leading technologies, understand those leading edge things like 5G and digital twins, and help them with their manufacturing operations. And so I get to help our customers, but I also get to help our internal sales teams understand that so they can help their customers as well. So I've been doing this for quite a while. I've worked for Cisco. I've worked for Rockwell Automation. I worked for an integrator in the past, as well as a manufacturer. So I have a really unique perspective, and I see this from multiple different angles. And so I think that brings a lot of ability to help in this space.
Very good. Yeah, you're a perfect person to speak to you then in terms of the industrial Internet of Things, Industry 4.0, and smart manufacturing. So maybe we can start with you giving us an overview of what it actually means for manufacturing. What does Industry 4.0 and smart manufacturing mean?
It's a great question. And I think a lot of people have heard of industrial internet or industrial IoT or smart manufacturing or industry 4.0 or smart factory. There's a lot of different names for this, but really the bottom line is it helps. It's really to apply technology to make manufacturing more efficient, more flexible, more sustainable as well. I mean, this concept's been around for quite a while. And really the idea is to drive outcomes and not just throw use cases or applications out there. And that's where the industry's shifting a little bit. They're driving those outcomes. You can find it multiple places. Aberdeen Group says if you do this the right way, you can reduce your downtime by 3.5%. You can improve the utilization of your factory by 11%. You can increase the total production output of a factory by 10%. If you get to that point, I mean, that's real money to the bottom line. That saves you from maybe even having to open another factory, because you can be much more efficient with the assets, the plants, and the personnel that you already have. But really, that's just the beginning, because this is starting to transform, starting to accelerate quite a bit.
Very good. So, and how is Industry 4.0 changing? You said it's been around for a while. Maybe you can paint us a picture of what is changing and how you think it will look like in the future.
Sure, absolutely. In the past, manufacturers would focus on things like those use cases like predictive maintenance or connected worker or OEE, overall equipment effectiveness. Really, the manufacturers are seeing that that's that the potential is there and that the ability to do those outcomes are there, but they're really starting to say, okay, what else can we do? And they're looking to do more. They're looking to do things like, how do we connect our manufacturing output with our customers? So we know exactly what our customers are looking at. Let's really ramp up, ramp down, change what we're manufacturing. We want to be able to do things. They want to be able to do things like automate the supply chain, right? We've seen that in the last year or 2 years, is that supply chain being a real challenge. And they want to connect directly to the supply chain, their manufacturing capability and manufacturing output. Things like traceability, that's going to require a lot more technology, and it's really becoming required by authorities, as it's even becoming a legal requirement. And then, like I've mentioned earlier, sustainability and that circular economy, and having energy reduction as part of what you're doing, and that's going to require a lot more connectedness, a lot more technology. And so, what we at Dell call, a lot of people said smart factory, we're looking at shifting that to the remarkable factory. And so, instead of things just being a little bit more efficient, we're adding new capabilities and starting to think outside the box and say, all right, well, what if a worker doesn't go look for a part, that part actually finds them at the right time, at the right place in their assembly line? What if a machine detects its own problems and then schedules repairs during a downtime, right? What if the production automatically ramps up or ramps down or schedules itself based on energy usage and what the demand is and what kind of, the prices are? But, these are all these really interesting things that are coming up, but we're going to need a lot of new technology and a lot of things, that emerging technology that are coming along to make that happen.
Very good. I'm just having a quick look through the stream. People saying hello from different parts of the world. We have Javier joining us from Paris in France. We've got Eric from Kenya in Africa, Cedric from Belgium, Philip from the UK. We have got someone from Dubai and Kevin saying Kansas City, yay.
All right, Kevin.
Yes. And we've got someone from Sweden. So amazing. All over the world, people are
That's
joining us.
fantastic.
As
That's great.
always, if you have any specific questions for us and for Todd in particular about Industry 4.0, as always, feel free and fire away. So you talked about new emerging technologies. So what are the emerging technology domains that will help us get to this new Industry 4.0 that you've outlined?
Well, I think you mentioned them, and it seems like the buzzwords, but and we're in an interesting time in history right now, because those buzzwords, those new technologies, are really definitely, it seems like they're made specifically for increasing smart manufacturing Industry 4.0 and helping accelerate those initiatives, right? Number one, 5G networks and the connectivity that they're going to provide. Number two, digital twins and the game-changing capabilities that'll introduce. AI and machine learning and the focus on big data, right? They're interrelated in that the better the data, the better the AI, and vice versa. And then edge compute and the hybrid cloud capabilities that are emerging, that are really going to be important for this smart manufacturing Industry 4.0 initiatives going forward too.
Yeah, so many super exciting technologies. Maybe we can look at them in a bit more detail, in
Sure.
maybe starting with edge computing. From your perspective then, what does edge computing mean for the smart manufacturing and for Industry 4.0?
Yeah, absolutely. A lot of manufacturers are very hesitant to embrace the cloud. And one of the things, and we can talk about it a little bit later, but one of the things I like to talk to them about is the cloud is not a location; it's a way of doing business, and that cloud can really be cloud consumption models at the edge. And when we talk about edge, we're really talking about the next generation of edge, and not just gateways sending data to a cloud, or not just industrial computers sitting down on a factory floor. It's really starting to push that enterprise grade compute capability that we're used to in the IT worlds, and that hyper converged compute capability, pushing that down to the factory floor to run those applications. 81% of manufacturers surveyed by Dell said that the edge will go down in history as one of the biggest transformations in computing. And I happen to agree. I also think that a lot of manufacturers have gone about this kind of in the wrong way. They typically look at it from a use case point of view, and they think, okay, here's a proof of concept. Let's put a computer somewhere. Let's run an application on our manufacturing floor. Then let's do that proof of concept and scale. The problem is, according to McKinsey, only 30% of Industry 4.0 programs have really made it to that scale point. So I'm going to tell you a secret, and it might be a little bit controversial here, but I think proof of concepts are a waste of time and a waste of money. The data is there. You can look at McKinsey, you can look at the World Economic Forum. The ROI is there if you do this the right way. If you look at it from a point of view of, let's build our edge infrastructure first to run all of those applications, all of those use cases that we know is coming. So to get to that outcome point of view, to get to the outcomes you expect, you're going to need hundreds of use cases and dozens of applications. What are you going to run that on? You really need to have enterprise grade infrastructure and build that out first, rather than say proof of concept, where are we going to run it? Let's build out the infrastructure, because it's going to need to be there. You're going to need to do that to run those many, many applications. And really, that's an infrastructure first approach. We're seeing a lot of the best in class manufacturers across the globe really look at that and go, yeah, you know what? That's what we're going to do. We're tired of proof of concept purgatory. We're going to say, all right, let's invest in our infrastructure first to be able to do that. And it's an edge infrastructure, right? It needs to be edge because of the performance, because of the scalability, because of the security, because of the data sovereignty issues that can come out of that. And those outcomes that you are going to deliver are really only as good as that infrastructure it runs on, right? So really, you build that infrastructure, that edge infrastructure, and then worry about, all right, what's the cloud? What's our cloud strategy after that? Are we on-prem cloud? Are we colo? Are we a hybrid cloud? Are we multi-cloud? And the answer at that point can be yes. You get to choose wherever you want to go, wherever that data needs to go.
Yeah, so I guess many manufacturers are more familiar with the cloud, where you basically have your data stored in a way that they can be on premise, off premise, but usually managed by someone else. You then have edge computing, where you push more of the computing to the edge of the network, onto machines, onto the shop floor.
Yeah.
Staying then on a bit longer on the edge computing element, what do you see as the key use cases for edge computing in manufacturing? Do you have any good examples of any of your customers or anyone that you know of that has implemented this well and is using edge computing to really deliver value?
Yeah. So I mean, there's a lot of the typical ones that everybody is looking at. I mean, I mentioned a little bit about them. Predictive maintenance is going to be key. I think predicting when your machines are going to go down. I think overall equipment effectiveness, OEE, is another really good metric to say, all right, let's get more out of the assets that we have. Let's look at things like just plain old plant visibility. Can our CEO see what's going on in all of the plants across across the country and have a centralized dashboard? Most answers right now is really no, right?
Mm.
And so to get to that point of running those specific use cases, and we see this all the time, customers doing that. Connected worker, for example, just getting rid of clipboards and paper on the factory floor. That's going to require that type of infrastructure. And then once you have those applications and you know that those use cases are going to deliver that ROI that you're going to need to be able to implement this, then the next step is, all right, what are those applications that we haven't even thought of yet or that aren't quite mature yet? Things like digital thread, things like digital twin, advanced analytics, AI, machine learning workloads that are going to go down there, that you really haven't even thought of, that really haven't been part of this yet. But if you've got that compute infrastructure ready to go, then it doesn't matter. You can layer on whatever applications you want. And you don't have to specifically engineer something or re-engineer your infrastructure or re-engineer all the things on the plant floor to be able to make that happen.
Excellent. Just one little audience question here from Angel saying, if proof of concept is a waste of time, how do we justify the big investment of jumping to edge computing?
Great question. And I mentioned it just in passing. The World Economic Forum, in combination with McKinsey, has done some really good research, really good work on lighthouse manufacturing accounts, and basically proving out that you can expect this kind of return on your investment if you do this many not proof of concept, this many use cases.
Mm,
So the idea is to look at it from not a use case point of view, because you're going to have many use cases. I've talked to a manufacturer of automobiles. They've got over 160 use cases on their list of things to do, right? So instead of going at it from an individual use case point of view, build out your infrastructure, then you can run all of those on there. And like I said, things like Aberdeen Group's been pretty good about showing how that ROI is there if you do all these use cases. Again, it's going to take you a lot of use cases to get to those specific outcomes, and to get all those use cases, you're going to need that infrastructure. And the proof of concept piece, there are multiple places out there. World Economic Forum is a really good one. There's some free research, free documents out there that you can take a look at that really walks through that really well.
great, thanks. I can't wait to talk about all the other super exciting concepts like digital twins and AI and some of the other topics. But before we do this, you mentioned the cloud. And how do you feel cloud fits into the future of Industry 4.0?
Cloud is going to be really important. I mean, you need to have that connectivity across geographies. But I think it's important to think that the cloud, like I said before, is really an operating model. It's not necessarily a destination. So in the cloud, you're buying compute resources and somebody else is taking care of them. You're buying these compute resources as a service. Having a hybrid cloud, which really includes edge compute and infrastructure at the edge, you can consume that as a service as well, and then reap the benefits of having that local, the benefits that it's going to be higher performance. It's going to be much more reliable. It's going to be, in a lot of cases, lower cost. IDC says that hybrid cloud's going to lower your TCO by about 47%, right? So, the public cloud is a lot of times is very easy because they make it really easy to get that data and push that data really quickly into the cloud. But it's a lot more expensive in the long term and even the midterm too. So what we talk about is having that cloud as a consumable resource, but a lot of times you can have that on-prem. I talked to a manufacturer about a year and a half ago, a really large global manufacturer, and they said, all right, we're going to do cloud. We're going to do everything to the cloud. We're going to push everything to a public cloud, and we're cloud first. And then they even became cloud only. Well, a year later, their cloud spend went from $40,000 a month to over 10 million US dollars a month. You can buy a lot of infrastructure with that kind of money and have a lot better performance and reliability.
Fascinating. So I completely agree. I think hybrid, cloud, edge, super important. Another topic that you mentioned is data and artificial intelligence, machine learning topics that are very close to my heart, and I talk a lot about those.
Yeah,
From
I
your
know.
perspective, then, how will manufacturers leverage data and AI?
Yeah. Our president and CEO, Michael Dell, says that this is the data decade. And so from him to our global CTO on down, it's a big focus for Dell, especially in the manufacturing space. There's massive amounts of data coming from new applications, right? Video is going to be big, analytics, AI. That's huge amounts of increase in data volumes. And so 90% of that data didn't even exist 2 years ago. And I know that you like AI and you like supply chain. Like everybody is very interested in that today. And there was an IDC prediction that 50% of all supply chain forecasts are going to be automated using AI. And so to do that, you need to have that connectivity down to the plant floor, as well as what your, know what your supply chain is doing to make those connections.
Mm.
So manufacturers are going to need to really have to use new techniques to collect, process, store, back up all that data. And really what's emerging is a more unified approach. And typically it used to be different silos. Manufacturing or one particular area in the plant had their own approach to handling data, and the data center and IT had another approach, and then this over here had another. So emerging is a lot of much more unified approach to managing, handling, storing, and doing something interesting, running AI analytics workloads on that data. At Dell, we see as well that there are different data domains emerging, right? The standard data domain, spinning media, solid state media in a hard drive somewhere, sitting somewhere, that's your standard. But we're seeing then the emergence of things like a hybrid cloud, like a cloud integrated enterprise grade infrastructure, enterprise grade data domain, so that it's not just available just in one place. You can have access to it across multiple locations across the globe. And that's an important distinction, and to make sure you build that into your next generation of smart factory industry 4.0 initiatives. The third one that we see too is high performance. When you're doing analytics and AI workloads, and computer vision and those GPU accelerated workloads, there's a high performance data domain that starts to emerge too. You don't want to typically use that same type of data and that same type of data storage and handling mechanism for your standard data, because that's a much higher cost, a much more expensive data domain, if you will. So when you develop and you look at your AI and machine learning initiatives, make sure you take that in consideration when you're building that infrastructure to handle all of that.
Yeah, and I guess once you have the edge and cloud infrastructure in place, you have your big data feeding into it. It is then a lot easier to start using it for machine learning and AI, because lots of the cloud infrastructure providers have plugins that you can simply switch on to use some of the amazing machine learning capabilities that are now available with pre-trained models.
Yeah.
Do you have any examples? What are your favorite examples of AI then in the manufacturing world?
Well, I mean, it's it's emerging. I mean, there's all different types of AI, and people like to confuse AI and machine learning. And I think the AI portion is how it interfaces with a human, and how it takes that natural language and does something interesting with that. And so, we're seeing that with private mobility. We're seeing that with connected devices. We're seeing that type of stuff. But then we're starting to see the machine learning portion, and that machine learning is looking at data and doing things in the background to come up with new ways of looking at how your manufacturing is being structured, how efficient it is, and where it's headed and where it's going, and using that for things like digital twins, and using that for things like production scheduling, using that machine learning for those things like predictive maintenance. That's another really big opportunity for machine learning, because
Mm.
with predictive maintenance, either you have somebody that knows a specific machine really, really well, and you write a program around that, right? And that's a very, very small portion of the predictive maintenance market. I actually worked with a company that did predictive maintenance on a robot, and they took a guy named Brad, who was their service manager for many, many years, and they really picked his brain and created an application around that. They called it Bradalytics. But not every single application can be done that way. So you have to start looking at machine learning and observing faults and observing downtime to be able to start building those models that say, okay, now I can predict when that's going to happen.
Very good. The other piece of this whole smart manufacturing industry 4.0 jigsaw puzzle is 5G. And what role do you envisage 5G playing in the future of manufacturing?
Yeah, this is very interesting, and some people think it's a little controversial too. But I think it's perfect for manufacturing. If you look at most manufacturing plants have a ton of massive technical debt. They haven't really thought about or needed to connect all the devices or build an infrastructure that is sufficient to handle analytics. I like to call it accidental architectures that have just evolved over the years rather than being truly engineered and truly designed. For a lot of those factories, 5G can be that easy button. It can accelerate their Industry 4.0 transformations because of that connectivity, that pervasive connectivity. We're early stages, no doubt, but that 5G capability really gives you things like network slicing. So you can have VLANs built into the air, basically. You can have better management and even better security in a lot of these cases as well. So when you marry that 5G with a hyper-converged infrastructure, an edge compute infrastructure that is hyper-converged, the advantages of hyper-convergence give you all of this massive amounts of compute in a centralized location, making it much easier to scale, manage, secure, and take care of. And then you add 5G to that. So you basically expand that computing and giving you really virtually unlimited computing power anywhere you need it. So you've got ubiquitous computing across the plant floor. So you've got hyper-converged infrastructure providing hyper-distributed compute. That's going to be a big game changer. So you can have a device on your head that is tiny, but harnesses the power because of the bandwidth of 5G, harnesses the power of a giant computing cluster located in the next room. And that's going to really make, it really change the game here.
Yes, and I think it's really important for manufacturers to understand that they don't have to wait for a national rollout of 5G to reach their factories, that they can have a private 5G network installed that will give them all the benefits straight away.
I agree. And thanks for pointing that. I typically, like you just figured out, I go to private 5G inside a manufacturing plant, but a lot of the public 5G too is an important part as the backhaul and as other types of manufacturing and Industry 4.0 implementations may be outside and distributed, outdoors and that type of stuff. But you're exactly right.
So another topic that you've mentioned a few times already, and that this is a key focus of your job, is digital twins. So maybe we can start by defining what they are.
Absolutely, yeah. There's a lot of interest in this. This is accelerating quickly. So digital twins are a virtual representation of physical objects, and that physical object doesn't necessarily have to be an object. It can be a building, of course. It can be a process. It can be an organization as well. The Digital Twin Consortium, and Dell was one of the founding members, and we're still really involved with it because it's really interesting and scaling up fast, and it's a lot of really smart people there that are converging to make that happen. They define it as it's a virtual representation of real world entities and processes. And this is the important part. This is where a lot of people kind of miss the digital twin part. Synchronized at a specified frequency and fidelity. So that last part is key. It's not just a 3D model of something. It's a 3D model of something that's getting updated in near real time, or however you want to define real time, depending on the use case and what you're going to use it for. It's really important to say, okay, I've got a true representation of this process, of this object, of this asset, of this entire factory in real time, and it's updated in real time. So it's what's going on in that factory right now. Or I'm a believer that the digital twins are going to be a big part of our everyday life, right? So I'm going to wake up and my smart home twin is going to connect with the utilities twins, and it's going to schedule when my dishwasher runs and my heating goes on and when I can water my lawn. I'm going to have health twins, and I'm going to have twins of every one of my young children, and I'm going to know when I wake up what their blood glucose levels are, and so I'm going to know what kind of lunch to pack her in the morning so that to help her take care of that. A smart city twin is going to say, okay, you're going to have a lighter traffic to get to your appointment today, so stay home and have another cup of coffee with your wife. Or a financial twin is going to say, all right, I'm going to look at everything, my personal finance finances and say, all right, here's your bills. I'm going to estimate, I'm going to calculate the savings. I'm going to actually do some of that savings work. I'm going to ask permission. It's going to ask permission to pay bills. It's going to run through multiple investment scenarios on my investment portfolio, and I'll do that in real time and let me have that control. It's going to also say, hey, buy NFTs. No, I'm just kidding.
Fascinating. So in the manufacturing world, then more specifically, have you got any examples of customers or companies that you have worked with or have observed that is using digital twin technology well?
Yeah. So we're, this is an accelerating field, and we really haven't seen any one specific player come out with the end-to-end digital twins. There's a lot of really good partners. Dell's partnered with a lot of those different people in this space, and they're coming out with some really interesting things. But one of the things, and I'm focused specifically on manufacturing, and really the right digital twin, and there are some real good partners that we have that are already focused on that. That digital twin will incorporate and will merge really all of the smart factory industry 4.0 use cases. It can really kind of take care of that in one swath. If you do that digital twin right, you can predict the maintenance, you can look at OEE, you can have plant visualization. Then in addition, you can improve the operating of that factory, because you then incorporate other assets, other machines, other packaging machines and assembly lines into that digital twin, and then run that AI and machine learning simulations on top of that to really say, okay, this is the best process, this is the best procedure, this is the best configuration of my factory, and it's all run from these digital twins. BMW right now can do that. They're doing that in one of their assembly lines. They can, before you have to move around all the heavy machinery, they can do that all simulated. They can all do that from a digital twin point of view, and save the time that it takes to really move all that around, and save that up by 25%. So that's a really key differentiator. We're seeing people apply digital twins in their supply chain too. And again, the supply chain is really huge right now, as we all know and all feel. And so modeling that and using a digital twin of your supply chain and connected with your digital twin of your factory can really, really avoid some of those problems that we've seen in that supply chain. It's really, it's a platform to develop the next generation of applications that we haven't even seen.
Very good. I'm just looking through this stream, and there's a few people asking about cyber security, and any concerns around this, because we're talking about all this digitization here. With all
Absolutely.
of this come huge risks. Any views on that?
Yeah, absolutely. It's imperative. It's critical that security be built in. Security is no longer just a bolt on, right? That a lot of people used to think, okay, let's build it. We'll bolt on some security or throw a firewall here or there. It has to be intrinsic security built in from the ground up. A former colleague of mine at Cisco used to call, smart manufacturing security right now a hard shell with a soft middle. And that's because, you put in these walls on the outside, but inside it makes it real challenging. So some of the new technologies, we call them new, but like microsegmentation down to the edge level, those kind of things. But again, it has to be built in. I mean, we could have an entire conversation, entire couple hour long podcast, probably not with me. I'm not to that level around security and what you need to do there. But the key is everything that you put into these type of smart manufacturing initiatives has to be secure, has to have intrinsic security. The zero trust is a big thing that's coming along, and that has to be built in as well. But it has to be built in from the ground up. It can't just be a bolt on anymore.
Very good. And there was another question. I'm just trying to find this. When you were talking about digital twins, we're also then entering this whole new world of the metaverse. Any views on that? The role of the metaverse in manufacturing?
Yeah, there's the metaverse, and the metaverse with the trademark a registered trademark piece that are on it. And so I'll probably stay away from the registered trademark piece, but the metaverse, it depends on who you're talking to. It depends on the specific definition. And the metaverse can be just a 3D simulation of what's going on, and that's digital twin all the way with the AI and machine learning that layers in on top of that. A lot of people will add in the Web 3.0 and the decentralized part of what that incorporates. I mentioned NFTs before and cryptocurrency. There's definitely going to be a place to play for that decentralized stuff. But the key thing to remember about blockchain, about in some people's version of the metaverse, it is about decentralization. And I think so far what we're seeing in this industry, manufacturers want to really centralize what they're doing. They want to have control over what they specifically are. If you own 350 manufacturing plants across the globe, you probably want to really have a centralized look at those and a centralized control. And so Web3 or decentralized blockchain capabilities aren't going to be as important in that part. I'm not saying they're not going to be important in other pieces of it, having a market for your data, like an open market for digital twins, or that's going to be key. I think blockchain and metaverse are going to be really interesting and really keys to some of that. But if you're a manufacturer trying to be a smart factory or a remarkable factory, there's not so much of the metaverse, other than if you're just thinking about a 3D simulation and AR VR kind of pieces that are going to be really key. So we can talk a little bit more about AR, VR, but it depends. Again, it depends on what the metaverse is.
Yeah, and I just before the whole concept of the metaverse exploded, I published my book on extended reality, and in which I talk about everything but the word metaverse. And
Yeah,
and for me, there are huge use cases around augmented and virtual reality,
no
especially
doubt.
when it comes to digital twins and manufacturing.
Right. I completely agree. And if you think about it, a maintenance worker dons a pair of glasses and walks out onto their factory floor and can look through a conveyor or a guard or pipes and look into the inside of a machine and see that a motor is overheating, right? Or see exactly how to replace a specific part on the inside of an engine for a helicopter, right? I mean, there's huge opportunities for that XR, as you said, in multiple different areas. And again, that goes back to an infrastructure to make sure that happens, because your maintenance worker isn't going to want to carry around a PC under their arm. They're going to want to have connectivity back to a considerable amount of compute horsepower that can make that XR reality real. So, yeah,
Absolutely, and even trying out replacing a part in the virtual world before you then do it in the real world. Absolutely.
yeah, absolutely is right. Yep.
You talked about so many amazing technologies here. I could go on forever, but um, there's this sense that all of these technologies obviously influence each other. They connect with each other to help create this new world of smart manufacturing, or remarkable manufacturing, as you call it. So how do these technologies connect then to help us create this next industry 4.0 world?
So that's a good question. So we look at it from a point of view of that, we start with 5G. 5G simplifies that data access and really improves the data quality and connectedness. That better data then, and the data management that goes with it, leads to much better machine learning and AI. And that machine learning and AI makes the simulation and 3D modeling and XR capabilities even better. And that simulation and XR and 3D modeling will make better digital twins, more valuable but digital twins. And then those digital twins, as well as AR, VR, XR, will make smart manufacturing much more reliable, because you have that capability. You have this giant palette with which to paint whatever masterpiece you want in your remarkable factory.
Wonderful. Thank you very much. Looking forward then, are there any technologies that you are particularly excited about? Thinking these are things that I have on my horizon to watch. I mean, we've looked at some super innovative technology today already, but is there anything else that you think actually I'm watching this. This could have an impact on manufacturers in the future?
Yeah. All those that we talked about for sure are still, a lot
Mm,
of them are developing in different areas and at different levels. I think quantum computing is something that just fascinates me. I
mm.
don't know if I completely can wrap my head around all of it, but I think quantum computing is going to be a really interesting space here. Um, I think 5G is really kind of in its infancy, especially the private 5G.
Mm.
So I'm thinking, kind of put me on the spot here, but we talked about a lot of these things. I think digital twin is going to make a lot of that. A lot is going to incorporate a lot of that stuff as well. And so,
I
I mean,
agree. I just wanted to make sure because everything we talked about are super innovative technologies that are pretty much at the beginning of their
yeah,
life cycle, and I agree with you. I think quantum computing is further along. I think blockchain technology to some extent is also slightly further along, but could have a
yeah,
big impact on supply chains. But
I think
other
you're
than
right.
that, I agree. Those are the key technologies. So fascinating. I could go on forever. This is the time for us is up now. Anyone who would like to rewatch this conversation, you can head to my YouTube channel, or you can go on LinkedIn where you can see this. And you can also on my channel find hundreds of more videos and conversations that you will hopefully find interesting. So for now, thank you so much, Todd, for your time today. And thank you for everyone joining us, listening to us. And as always, let me know what you think. And if you have any ideas about any future shows, let me know. Thank you,
Bernard,
Todd.
thank you. It was a pleasure.
Thank you.